AI intersect AJ for all of them is at least 1.
Mm-hmm.
And it says prove that there exists A is in at least 5 subsets.
Mm-hmm.
So try to use a small example on 5.
On 5. So like you're saying,
Yes.
like use like
For example, it's
at
in
least
at
like
least one element. If it's in one subset, it's correct, right?
yeah.
Then try to prove 2, then 3, then 4, then 5. So 1 was obvious. So try to see what's the maximum number that you can prove. Okay, then reach. Right.
Okay. I don't know how to solve this.
Okay, so let's try. You could prove until which number here?
I'm stuck on 2. I don't get what I'm supposed to do.
Okay, so
I
let's
just wrote
try it for 2. So let's
I
use
just wrote sig
You said what?
I just wrote sigma di choose 2 greater than 10 choose 2. I don't know.
Okay, so let's consider this one is m is 5. If m is 2, we want to prove there exists x that is in at least 2 subsets, so we can use contradiction, right? So it means that each element is in what?
1 subset or 0 subsets.
Yes, so here it is at most 1, at most 1. So, because we have 3, so this one would be what? 3, 3, 3. AI intersect AJ is at least 1. So, because
Yeah.
AI intersect AJ is at least 1, we know that for each 2 of them. So it is at least what?
10 choose 2.
But because maybe, for example, n is so much large, right? Do you agree if a degree of one of them is 0, we can remove that vertex and it has no effect?
Yeah.
So we can consider all of them are 1, right?
Okay.
Okay. Then do you agree if all of them be 1, we don't have anything like this?
Yes.
So do you agree it would be 0? And that's a
Yeah.
contradiction because it is at least 10 choose 2.
Yeah.
So we proved 2. Now try to prove 3, okay?
No. Using the same like
Yes,
strategy.
it's similar. Like this, you can go 3, try to prove 3.
So if I do it 3, then I get the number of like those AIAJ 2-step paths is greater than 10 choose 2, greater than or equal to 10 choose 2,
Yes?
but then it's also less than or equal to n.
Less than or equal to n. Okay, let's check.
Because each 1 to n point can only have 2 lines going out of it.
If we use contradiction, it means that for each of them it's at least 2, right? And do you agree when the degree is 1, it has no effect on this part?
Yeah.
So do you agree for satisfying this, we can only consider the vertices that the degrees are 2, right?
Yeah. Okay.
Okay, so A1 to A10. So I consider only the things that are 2. I don't consider these things that are 1. And if we consider this part, suppose 1 to n. Okay, so number of AI choose, number of these is equal to n choose 2 is at least 10 choose 2, right?
Yeah. Oh wait.
Okay, so n is at least 10, right?
Why is it in?
I said if one of them is not connected to these things or only connected to one of them,
I mean, why?
it has
Why
no
isn't it
effect
just
on
n
this.
or
Why you said n?
n?
Sorry. It is not n choose 2. It is n exact, right?
Just n. Yeah,
N times 2 choose 2. So n
yeah,
is at least 45, right?
yeah. Which is too large, I think, because then there's
Then what's the
there
problem? Because we have
because
45,
from
some number of edges. 45 times 2 is equal
yeah,
to 10 times 3, number of edges. We have
yeah,
45 times 2 plus something else. So 45 times 2 is less than or equal to 10 times 3, 30, 90. So we reach a contradiction, right?
yeah.
Okay, now you prove 3. Want to prove 4 or want to jump to 5?
I'll try and prove 5.
Okay, so try focus on 5.
I'm confused now because if you write 10 choose 2 less than or equal to 4 choose 2 times n,
Let me write.
then
Uh, Here A1 to A10.
so now I assume each n is at most four
Exactly.
things.
1 to n. Each of them is at most 4. Then what?
Then you would say 10 choose 2 is less than or equal to 4 choose 2 times n. But then the issue is that it could be 3 at a point.
And now we want to calculate number of edges. If we calculate number of edges, it would be what?
Well, one side is 30. Well, it's always 30.
Less than or equal to?
4n. Oh, okay. Okay, 4n. And then from the first equation, you get n is greater than or equal to 7 point something. 7.5.
Yeah, so n is at least 8.
Yeah. Then from the bottom, you get. Oh, wait.
From here, how we reach contradiction? We said n is at least 45. Then number of
Yeah.
edges will be at least 2n, right?
Yeah.
So some of them
But
are
from the.
4, some of them are 3, some of them. So by this one, we cannot reach contradiction, right?
No.
Agree?
Yeah, it seems like you can't. Why? Okay.
Okay. One hint or one to try on your own.
I guess hint.
So we can
Shouldn't
do
be.
some what?
Wouldn't it be 30? No. Okay, never mind. Yeah.
30. We can say at most 4n. So from here, n is at least 8. Okay, so I want to do something. I want to say here that we have n. Some of them are 2. Let's consider they are A. Some of them are exactly 3B. Some of them are 4. And we call them C, right?
Okay.
So if we want to calculate this, it would be what in terms of A, it is at least 10 choose 2. And it is what in terms of ABC?
It's A times 2 choose 2 plus B times 3 choose 2 plus C times 4 choose 2.
Yes, A plus 3B plus 6C, right?
Yeah.
Number of edges is what we know is equal to 30. And it is equal to what in terms of ABC?
It's 2A plus 3B plus 4C.
And this one is 45.
Mm-hmm.
Now it's better because here we said it is equal to what, right?
Yeah.
Now consider these two things. Probably I think by considering these two we can reach contradiction. If not, you should find an example of A what, B what, C what to satisfy these two parts. Okay?
Mm-hmm.
Try.
Okay, wait. So I think what happens is if I subtract 2a plus 3b plus 4c from a plus 3b plus 6c. Then I get 15 is less than or equal to 2c
Let me
minus
write.
a.
You could reach contradiction.
I'm pretty sure, yeah.
Okay, can you explain again? Sorry, right.
So I subtracted 2a plus 3b plus 4c from the above inequality.
Okay.
So I get 15 less than 2c minus a.
This one minus this one, so 2c is greater than or equal to 15, right?
Yeah, basically. So c is greater than 7.5, but then
C
c
that
also has to be
8,
less than 8.
greater than or equal to. Yeah,
But c is also less than or equal to 8 because
because of
of
this.
that.
Exact.
So c equals 8, which is
Most,
not good.
at most 7 c here. So that's a contradiction, right?
Yeah.
Okay.